Good afternoon, everybody. The topic is the electric resistor tomograph, a technology in deciphering the interiors of standing trees. To be frank, this technology really it's having a great potentiality because this technology can be applied to solve many of the field problems because of the advantages which it's having. ERT is an advanced non-destructive tool, customized tree-specific novel German technology, which was developed to monitor and estimate the tree growth development by looking into the internal inner structures by giving the greater resolution with accurate precision in estimating the hardwood, sapwood, stress, decay, and even hollowness in the standing trees. Why this electric resistant tomograph estimation is required? Because it tells about the presence or absence of the hardwood, decay, hollowness in the standing trees, and also even in logs. If present, then it will help us to calculate the extent because it gives a three-dimensional structures when we measure. So this helps us to estimate the extent of hardwood, decay, or hollowness. And if the hardwood is present, then we'll be having a reason. If it is not present, then we'll be having a reason why it is not present. So what may be the reasons? We can think over it. And if there is any possibilities of inducing, if any new technology developed on that, that can be applied. So that farmers who are growing trees on farmland, if he finds that there is no hardwood, even after 8 years or 10 years, he can definitely think of inducing the hardwood formation in the standing trees. This instrument will help them. Next is, if you just look at the advantages in brief about the advantages of the electric resistor tomograph, the process of operating the instrument by tapping is tremendously very quick. If you connect the nails, if you put the nails around the tree circumference, and if you pass on a current, within no time, the image will be captured. Immediately, we can look onto this image by using a tree cloning software, which is very quick. Less cables are required. Around the sensors, minimum sensors, 8 should be connected, and up to 24 sensors can be connected to the entire tree. And this is totally harmless because just a pinch of a nail touching a sapwood is enough to pass the current. And insulated sensors gives for the instrument are very small, lightweight. Therein conducting nails are not driven deep inside the wood. It's not going to cause any harm to the trees. And system operates well. Even with the regular nails, what we get from hardware stores, even that will be of useful. And it is designed with new compact system, which consists of one chief control unit and no additional sensors or supply box are required. And once it is charged, it can be used for more than 50 to 100 trees in a day, and it's excellent. Approximate mass of this tomograph is around 4 kgs, which is very lightweight. Complete equipment fits into a small shoulder bag, and rugged transportation case is supplied, and also easy to as it's a portable device. And no personal computer is needed to be carried in field. In a small laptop or a tablet, having this software, tree cloning software, will work to generate the image, a tomographic image, and it can be used on field itself. Main control unit saves the data. Whatever the data we collect from the tree, it will be saved on a non-volatile memory device inside that device, and we can use it later on, even after many days. And there is an inbuilt GPS system. If you want, we can feed that GPS locations, everything it will sense. We can locate that. An inbuilt semi-automatic tree height measuring technology is also provided in that, which can be used. And this is having one advantage of what you call picus, the diameter measurement or the circumference measurement. And in that, where the precision and fast geometry, we can triangular functions will help us to calculate even the diameter of the circumference of the tree. This is a big advantage. And if you see in general, if you see the schematic representation of advantages, it is a non-destructive, easy to set up, very portable, multi-channel or multi-electroresistive system is there, multiple measurement in a single stretch, semi-automatic height detecting component is introduced, and GPS is also there in the system. And how the procedure of electric resistor tomograph does. First, we usually measure the circumference of the standing trees. Once we measure the circumference, we calculate the equidistance of measuring points If the measuring point is 8 minimum, then we multiply the circumference to 8. Then we'll note the measuring point to the second measuring point, what is the distance. Then we put according to the nails. Once nailing the measuring points at the breastplate is done, usually we take breastplate as a standard at the DBA shed, and then we'll connect these ERT sensors. Once it is connected, this we can, there is a catalog which is appearing on that ERT measurement. It asks whether a tree shape, which model should be, whether circular shape or a different geometrical shape. Then we have to select that shape. Once that model is selected, then we'll operate the system and we'll pass on some 100 resistance of 100 ohms of current. Then when the current moves from sensor 1, it moves all along the other remaining sensors, and the image is captured as histogram, and it will be stored inside this device, the ERT. And once the image is loaded on a tree drawing software, we can visualize that image, and we can further analyze that image and the tomograph what we obtained. This is how it works. And this is just what you call a typical ERT system. One is the processing vessel. We are going to fix the multiple measuring points and data acquisition done. Then go to computer, then image is constituted. Simple. There are many other equipments, especially for especially for hardwood and sapwood estimation. We just have a comparison with different equipments and non-destructive tools which were used in comparison with the electric tomograph. When we see that comparison was done with electric tomograph, with increment borer, sonic tomograph, and also electric impedance tomograph. If you see the hazardous level, the non-invasive method, it's just nails are being put on the surrounding circumference of the tree. So it is not hazardous. But in case of increment borer, it is invasive. Boring is done. A 6 mm boring is done, and it's dangerous because that may become a chance of entry point for fungus or the insects if it is not correctly being plugged with wax. So this may become dangerous in the later stages. And even in sonic tomograph, it is less invasive, requires hardware nails. And even in electric impedance tomograph, it is also less invasive, requires nails. And in case of electric system, we get 3 dimension. In case of increment borer, there is no observations or no visual observations can be obtained. In case of sonic, we get 2 dimension, and electric impedance tomograph, we get 2 dimension. So compared to this, all the ERT is advantage because it gets 3 dimension. When we get 3 dimension advantages, we can have an estimate, the entire estimate of the bowl or a tree if you want. And the mechanism is here, basically electric current is used on the voltage, and here the manual boring is done. Here sound waves are passed, and here the electric current is used in electric impedance tomograph. And in decay assessment, early stage of decay assessment can be detected. But in case of coring, it's not possible because the point of coring, if the decay is not there, it will not detect. It will not be known. And if there is any decay, there is a chance that the increment borer may stuck inside and it will be difficult to take it out. That problem is also there. And in case of tomograph, it do not show early stages of fungal infections. It can detect active and dead fungal stages. So early detection is not possible even in electric impedance tomograph. Instrument setup and portability, it is very easy and very portable, handy, just 4 kgs. It can be carried in a kit and bag, and easy to set up. And one of the important parts is the increment borer should be correctly covered. If not, a sharp end may harm. It may have the cut wounds. So it's very important. In kind of sonic tomographs, it takes longer to set up and clumsy to carry even. And even this impedance, electric impedance tomograph also takes a long time to set up. The software applied is Picus T-Tronics. Here there is no software. Here are Picus, and here Python-based software is applied here. And waxing the borehole, not essential, but it is very essential here in increment borer. And other 2 cases, it's not essential. The advantage, they determine the electric resistivity of hardwood and sapwood, determines the age. Sometimes if there is a growth ring, we can calculate the age, and growth, and also the quantity of the hardwood in the trees. And detection and quantification of decayed wood can be done. And detection of chemical properties of wood such as water content, iron concentration can be done with electric impedance tomograph. If you see the advantages, the disadvantage, only thing is a slight seasonal influence may be there, but that is not so much varying or impacting our hardwood estimation, because when we estimate the hardwood or sapwood content, even accuracy of 80 to 90% is more than enough. We don't need 100% accuracy in this. And here drilling causes little risky and infection of wood, wood color discoloration happen. Inability to analyze the wood, analyze the root systems, and requires many measuring points as possible in this. Next, after looking into this advantage and disadvantage, means the comparison with other tomography equipments, we just had a review of literature, and we have submitted a paper for sensing and imaging. It is almost in the stage of publishing. When we made a review of literature, the work has been done in many of these temperate species, conifers, pines. Many of the work has been done in and many countries like Austria, Germany, Australia, Queensland. There are many countries which have done the work, and majority of the work are restricted to the hardwood sapwood differentiation. In some cases, it is in case of palm, they have tried with the physium root rot or the stem rot, which is there in the main stem. And in major other cases, they have tried to, in China, they have tried with Quercus niger and Quercus virginiana. They have tried to understand the translocation or the what do you call, the liquid content inside the sapwood. They have tried. And in India, first time we tried with Tectona grandis ourselves using teak disc, which I'm going to tell further. This is actually the ERT, electric resistant tomograph. This is the case, the baggage case, where this electric tomograph is fixed, means carried using this baggage. And this is how it is being fixed at different heights if you want. And this is about the red sandalwood, and this is about the red sandalwood trees. Both we are measuring.